Good morning, my dear students. Hope that you all are well and you have completed the previous two chapters of mathematics. In this presentation, we are going to learn about the chapter 3, whole numbers. Natural numbers. Numbers are used to count things, that is 1, 2, 3, 4, etc. These counting numbers are called natural number. The smallest natural number is 1. The list of natural numbers is infinite, means there are endless number of natural numbers. It starts from 1 and goes up to infinity. Whole numbers. The numbers 0, 1, 2, 3 and so on are whole numbers. The smallest whole number is 0. One thing that is very important to note, that is all natural numbers are also whole numbers. 0 is a whole number but not a natural number. So we can say that all natural numbers are whole numbers but all whole numbers are not natural number. Successor and predecessor of a whole number. A whole number plus 1 is the successor of a whole number. Example, the successor of 5 is 6. That is 5 plus 1. A whole number minus 1 is the predecessor of a whole number. Example, the predecessor of 5 is 4. So in simple words, we can understand like this. Successor means a number after the given number and predecessor means a number just before the given whole number. Now here we will discuss about the fundamental operations of whole numbers. First, properties of addition. In that we have to discuss the first property, that is closure property. The sum of any two whole numbers is always a whole number. For example, 7 plus 27 is equal to 34, which is again a whole number. So if we add any two whole numbers, if they are added, the answer will always be a whole number. Next property is commutative property. The sum of two whole numbers remains the same irrespective of the orders in which we add them. Symbolically, we can write it as a plus b is equal to b plus a. For example, if we add 167 in the first place plus 352 in the second place, we will get the sum is equal to 519. The same 519 will be obtained as a sum if we add 352 in the first place and 167 in the second place. So, the sum of two whole numbers does not depend upon its position. This is known as commutative property. Next is associative property. If we have to find the sum of three whole numbers, we can add any two of the numbers and then add the third number to their sum. Symbolically, if a plus b is done first and then c is added, so we'll get the same result when b plus c is added first and then a is added to their sum. 0 is called the additive identity, which means if 0 is added to any number, the answer remains the same. So it is written here in the form of symbol like a plus 0 is equal to 0 plus a is equal to a. We can understand it like this. 2 plus 0 is 2 only. So 0 is called the additive identity. Properties of subtraction. Closure property. Subtraction of a whole number from an equal whole number or from a larger whole number always gives a whole number. For example, 12 minus 7 is 5, where 5 is a whole number. 12 minus 12 is equal to 0, which is again a whole number. Commutative property does not hold for subtraction. For example, if we take 12 minus 5, we get the answer as 7. But 5 minus 12 is not equal to 7. So, for subtraction, commutative property is not obeyed. The associative properties also does not hold for subtraction. Properties of multiplications. Closure property. The product of any two whole numbers is always a whole number. Example, 7 into 24 is equal to 168, which is a whole number. Commutative property. The product of two whole numbers remains the same irrespective of the orders in which we multiply them. Symbolically, we can write it as A into B is equal to B into A. So A multiplied by B will yield the same result as B multiplied with A. So we can see it with the given example. 4 into 2 is 8, as well as 2 into 4 is also 8. Next is associative property. If we have to find the product of three whole numbers, we can multiply any two of the numbers and then multiply the third number. It doesn't matter which two numbers we multiply first. Symbolically, A into B, if they are multiplied first and the product is multiplied with C, the answer will be same when B and C are multiplied at first and their product is multiplied with A. One is called the multiplicative identity because if 1 is multiplied with any number, the number remains the distributive property. If A, B and C are three whole numbers, then A into B plus C is equal to A into B plus A into C, and A into B minus C is equal to A into B minus A into C. Properties of division. For division, we have only one formula, that is dividend is equal to divisor into quotient plus remainder. Now from here we'll start the exercise questions, and I hope that all of you have understood all the previous topics that we have discussed here. So question number 1 is fill in the blanks. Dash into 65 minus 15 is equal to 35 into 65 minus 35 into 15. So as you can see in the first part in RHS, 35 is common in between the first term and the second term. 35 into 65 minus 35 into 15. So from both the terms we can take 35 common. So that comes in the fill up part, 35 into 65 minus 15. Third, 6142 plus 1236 plus dash is equal 6142 plus 1236 plus 3487. So this is based upon the property of addition, that the sum remains same irrespective of the position of the numbers. So in LHS we have 1236, which is missing in the RHS. So here in dash we will give 1236, and in the RHS we have 3487, which is missing in the LHS. That will be written in the dash part. Then fourth part, 68 into blank plus blank is equal to 68 into 36 plus 68 into 64. So we'll see the RHS part, 68 into 36 plus 68 into 64. Both the terms are having 68 in common. So we'll take it out of the bracket and we can write it down in the two blanks. In LHS we can write it down as 36 plus 64. Now question number 2. Find the sum and verify the commutative law of addition. So let us discuss what is commutative law of addition here. A plus B is equal to B plus A. So we'll add the two numbers given in the first part, 256, 479. Taking 256 in the first place and 479 in the second place, we are getting the sum 735. Then on the next side you can see, taking 479 in the first place and 256 in the second place, again we are getting the same sum 735. So A plus B is equal to B plus A, proved. Third, 52974, 2765. So we'll take 52,974 in the first place, added to 2765. We are getting the sum 55,739. On the RHS part, we're going to do 2765 in the first place is added to 52,974 in the second place, but we are getting the same result, 55,739. So again here commutative law of addition is proved, that is A plus B is equal to B plus A. Question number 3. Find the sum using most convenient grouping. First part is 3719, 286, 5281. So we'll see the ones digit of the first number and the last number, 3719 and 5281. If we will add them, 9 plus 1 will end up to 0, that is 10. So we'll add them at first. 3719 plus 5281, it is giving up the sum 9000 plus 286, so it is equal to 9286. Third part, 1841 plus 4477 plus 3459, 2673, 1223. So in this again we have to take the grouping in such a manner that we have to see the last digits of the given number, like 1841, the last digit is 1, 3459, the last digit is 9. So when we will add them, we will get the last digit as 0. So we are doing the grouping in that manner. 1841 plus 3459, it is giving the result 5300. 4477 plus 2673 plus 1223, so we are getting it to be 5300 plus 7150 plus 1223, which adds up to 13673. Question number 4. Find the products and verify the commutative law. So commutative law of multiplication is A into B is equal to B into A. First part is 126 into 63. So we'll multiply, keeping 126 in the first place multiplied with 63. So as you can see, I have given the multiplication product here. It is coming up to be 7938. Then we are doing the second part of the question, that is 63 into 126. So as you can see, we have again got the same product, 7938. So we are able to prove the commutative law of multiplication, that is A into B is equal to B into A. Question number 5. Find the product using most convenient groups. The convenient groups means we have to choose those two numbers which can be multiplied very easily with the third number, like 5 into 2, 10. Now with 10 you can multiply 2 very easily, it comes up to be 20. So we have to choose the numbers like that. I'm doing the second part here. 2754 into 5 into 21 into 20. So I'm making the group of 5 and 20 because very easily we can write it down to be 100. Then 2754 into 21 into 100. 2754 into 2100. So easily we can get the result as 5783400. Now question number 6. Find the products using distributive property. So first part I have done here, 231 into 11. In place of 11 I am writing it to be 10 plus 1. So 231 into 10 plus 1 in bracket. So when we will open the bracket, 231 will be multiplied with 10 plus 231 into 1. So we are getting 2310 plus 231, that is 2541. Second part we have to do in the same manner. 348 into 1001. In place of 1001 we will write down 1000 plus 1, and it is to be multiplied with 348. So we are getting 348 into 1000, that is 348000 plus 348 into 1. So it is coming 34800 plus 348. So the answer is 348348. Sixth part. Here you can see it is written 34,627 is to be multiplied with 9,999. So 9,999 we can write it down as 10,000 minus of 1, which is inside the bracket. Then 34,627 will be multiplied with 1000, minus sign into minus sign, then 34,627 into 1. So after doing the subtraction we are getting 346,235,373. Question number 7. Find the sum using relevant property. So I'm doing the second part here. 3056 into 92 plus 3056 into 8. So here in the sum you can see we have two parts, 3056 into 92 and again 3056 into 8. Both the terms are having 3056. So we will take them common. So 3056 is taken outside the bracket and we are getting 92 plus 8. So 3056 into 100. So very simply we can get the answer here. Now third part is again 93078 into 1786 minus 93,078 into 786. So from both the terms we can take 93,078 common and we are left with the bracket in which we have 1786 minus 786. So we'll do the subtraction of the bracket at first. So we are getting it to be 1000. Then 93,078 into 1000. Now fifth part is 322 into 678 plus 205 into 322 plus 322 into 117. Here we have three parts for addition, three terms for addition. All the three terms are having 322. So if we take 322 common from all the three terms, inside the bracket we will be left with 678 plus 205 plus 117. So we'll solve the bracket at first. We'll find their sum. Their sum is coming up to be 1000. So here we are getting 322 into 1000. Now question number 8. Divide and verify the answer by division algorithm. In division algorithm, we have already studied that we have to prove dividend is equal to divisor into quotient plus remainder. So for your convenience, I am solving the first part where I have mentioned the divisor, dividend, quotient and remainder. So first part is 452 divided by 257. We'll go for division. 257 into 1, 257. After subtraction, we are getting 158. Then 2 comes down. And then we are multiplying 257 into 6. So we are getting 1542. After subtraction, we are getting a remainder of 40. So here the divisor is 257. Dividend is 4152. Quotient is 16 and remainder is 40. So according to algorithm, we have to prove that dividend is equal to divisor into quotient plus remainder. So divisor is 257 into quotient is 16 plus remainder is 40. So we're getting the sum is equal to 4152, which is equal to the dividend. So the division algorithm is proved. Then the third part is 17,658 divided by 255. As you can see, I have done the division here, and after dividing we are getting the quotient 69, remainder here is 63. Then we will go for the division algorithm, divisor into quotient plus remainder. So 255 into 69 plus 63. So it is coming up to be 17,595 plus 63, which is equal to the dividend 17,658. Now question number 9. This one is very important. Find the number which when divided by 49 gives the quotient 45 and remainder 47. So here you have to only find out the dividend using the division algorithm, that is divisor into quotient plus remainder. Quotient is 45 given, remainder is 47 which is also given, and the divisor is 49. So we'll go for it. 49 into 45 plus 47. So the required number is 2252. Question number 10. Find the largest digit, 6-digit number, which is exactly divisible by 127. So to solve this problem, first of all we have to write down the largest 6-digit number, which is, we will write down in the following manner: 999. Now this number 999 will be divided by 127. So as you can see, after division we are getting a quotient of 7,874 and the remainder comes to be 1. Now here you have to understand that the remainder comes out to be 1. If this 1 would have been not there, we would have got the number completely divisible. See the last part of the division, 509, and we are getting 508. After subtraction the remainder is coming 1. So if instead of getting 509, if we would have got 508, then the number would have been completely divisible. So to get the required number, we have to subtract 1 from the largest 6-digit number. So as you can see here, I have only subtracted from 999. So we are getting 999,998. So this is the largest 6-digit number which is exactly divisible by 127. Now question number 11. Find the smallest 5-digit number which is exactly divisible by 273. So again here we'll start with the writing of the smallest 5-digit number, which is 10,000, and then we will divide 10,000 by 273. So as you can see, I have done the division here. After dividing 10,000 by 273, we are getting a quotient of 36 and a remainder of 172. After this, we can find out the required smallest 5-digit number, which is exactly divisible by 273 by the following method: 10,000 plus 273 minus the remainder. So 10,000 plus 273 minus 172. We solve the bracket at first. So 273 minus 172 comes out to be 101, and when it is added to 10,000, we are getting the required answer 10,101. This is the smallest 5-digit number which is exactly divisible by 273. Now exercise 3rd B. This one is very simple exercise, only you have to understand it and you can do all the questions by yourself. First one is find using pattern. First part, 7,854 plus 99. So in place of 99, we have to only replace it with 100 minus 1. So 7,854 plus 100 minus 1. So 100 will be added to 7,854. We will get it to be 7,954. Then minus 1. So the required answer is 7,953. Then the third part, 30,641 plus 9,999. In place of 9,999, we have to replace it with 10,000 minus 1. Now this 10,000 will be added first to 30,641. So we will get it to be 40,641 minus of 1. So the required answer is 40,640. Question number 2. Again in the same manner, find using pattern. Here we have to do the subtraction. We have to find out the difference. So 731 minus 9. Again, as we have done in the previous question, here also 9 will be replaced by 10 minus 1. So 731 minus, in bracket, 10 minus 1. When we will open the bracket, the sign will be changed. So 731 minus 10 and then plus 1. So 731 minus 10 comes here as 721 plus 1, 722. Then the third part is 198,754 minus 999. So in place of 999, 999, we will replace it with 1000 minus 1. Then we will open the bracket. 1000 will come in negative sign and minus 1 will come out of the bracket with plus 1. So first of all, from 198754, we have to subtract 1000. So we are getting 197754, then plus 1. So the required answer is 197755. Then question number 3. This one is important and it comes in the examination. So understand it nicely. 144 into 5. In place of 5, we can write down 10 by 2. It is the same thing. So in place of 5, we are replacing it with 10 upon 2. Now 10 upon 2. This 2 and 144 will be cancelled with each other. So we are cancelling here 2 72 times. So then 72 into 10, we are getting it easily 720. Then the third part, 488 into 125. In place of 125, we can replace it with 1000 upon 8. Understand it carefully. In place of 125, we are going to replace it with 1000 upon 8. So 8 and 488 will be cancelled with each other. So we are getting 61 into 1000, that is 61,000 answer. Fourth part is 96 into 625. In place of 625, we have to replace it with 10,000 upon 16. Once again, I'll repeat 10,000 upon 16. Then the 16 will cancel up 96 by 6 and we're getting 6 into 10,000, that is 60,000. Very easy. Now question number 4, 5 and 6 are of the same type. We have to understand the pattern. So we'll observe the pattern here. 1 into 8 plus 1 is 9. Then the first number 8 remains the same. As you can see in the first, second, third and fourth part, 8 remains as it is. Let us take a look on the first number, 1 into 8. Then in second case 1 2 into 8. Then 1 2 3 into 8. Then 1 2 3 4 into 8. So the next number will get it to be 1 2 3 4 5 into 8. Then for plus sign also you can see it is coming like this, 1, then 2, then the next 3, then the next 4. So next you will get 5, 6, 7, 8, 9 and so on. Let us see the result. The first result is 9, then the second result is 9, 8, the third result is 9, 8, 7 and the fourth result is 9, 8, 7, 6. So it is coming in descending order. 9, 8, 9, 8, 9, 8, 7, then 9, 8, 7, 6. So we'll get 9, 8, 7, 6, 5. Then 9, 8, 7, 6, 5, 4. Then 9, 8, 7, 6, 5, 4, 3. Then 9, 8, 7, 6, 5, 4, 3, 2. And 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Then question number 5. Observe the following pattern. We'll start with the LHS. 1. Then in the next line it is 1 1 plus 1, that is 11 plus 1. Then the third line is 111 plus 11 plus 1. Then the fourth line is 4 times 1, then 111 plus 11 plus 1. So the number of 1 is increasing. So the first part that we have to find out, the answer is 5 times 1, then 4 times 1, then triple 1, double 1 plus 1. Let us go for the answer. As you can see the RHS in the first part, it is coming 1 2, 1, then 1 2, 1 2 3, 1 2 3 4. So as you can see here it is going in the ascending order, increasing order. So the next answer will get 1 2 3 4 5. Then the second part we have to add like this, 6 times 1, then 5 times 1, 4 times 1, 3 times 1, 1 1 plus 1. So we'll get the result as in the increasing order 1 2 3 4 5 6. Then question number 6. Again here we have to understand the pattern. See the LHS. Here we are adding the even numbers, 2, then 2 plus 4, then 2 plus 4 plus 6, then 2 plus 4 plus 6 plus 8. So next we will get 2 plus 4 plus 6 plus 8 plus 10. Next we will get 2 plus 4 plus 6 plus 8 plus 10 plus 12. Then plus 14 and so on. Let us see the RHS. The first one we are getting 1 into 2. Then we are getting 2 into 3. Then 3 into 4. Then 4 into 5. So next we will get 5 into 6. Next we'll get 6 into 7 and then we'll get 7 into 8. If you have any doubt in these 3 questions, as these are very important, repeat the video again and again and you will be able to understand it nicely, because these are very simple questions. So your assignment for this chapter will be do all the questions given here in your notebook. Thank you and have a nice day.